Alright, time for a new tab. We are gluing this in on page 113. 112 will be blank. 112 just needs to say Unit 5, as does 113, where we're gluing in this tab. So as always, we're just going to cut off the little piece here, glue it in, then we'll get started on the lesson. So it just hangs off barely there. It hangs off a little more than normal. Alright, today we're going to, in this video and in the next video, we're going to be talking about trigonometric ratios. Now, if you are in physics, you should have already talked about these. It technically should be a review, but if you're not, I am going to obviously teach it in a way so that if it's your first time, it's going to be fine. So we are going to work on pages 114 and 115. Today we'll be on 114, tomorrow on 115. So go ahead and turn to 114 and we're going to label it. And technically this is considered 2 lessons in 1, which is what we're going to do for the next few days. Okay, so go ahead and label 114. We're going to work on 114 today with the foldable that you have been given in your at the bottom of this video.
Keep an open mind. That on your second or third attempt, maybe it'll be better. Okay. So, trigonometry means triangle measures, so we're going to be measuring triangles. However, we're first going to start by just finding the ratios. We're not actually finding anything in a triangle. I told you guys to get your straight edge out because it really bothers me that no matter how dark I made this, it doesn't look like a triangle, but it's supposed to be. So please draw this back and then you can put your straight edge back up. One of these days, but I always forget to order it until it's time to teach this, I want to order the shirt that says opposite, adjacent, and hypotenuse. It's got a hippo laying across the thing. Sorry you're going to miss that one of these days. Yeah. And it says hypotenuse. Not if it's a strong enough opposite and adjacent, it would. If the other legs are strong enough, it'll hold it up, is what I said. Yep. Welcome. Okay, guys. The trigonometric ratios. Sine, not sin. We're not sinning. Don't say sin. I will stare at you until you fix what you said. It is sine. Sine A. Sine of A is equal to opposite over hypotenuse. That's where this part comes from. Soka, Toa. Yep. Cosine of A is adjacent over hypotenuse. That's where this piece comes from. And tangent of A is opposite over adjacent. This is what I'm talking about. You could have a pop quiz on this week. Memorize these. Can't spell memorize. You will have a pop quiz. It may be this week. It may be next week. It may be next month. You'll have a pop quiz on those. At the end of class, if you'd like some note cards to make some flashcards, I'll give them to you. Alright, so open this. The hardest part, I think, of these is understanding what the question's asking. So, for instance, example 1 and 2 say find the sine, cosine, and tangent for the indicated angles for both A and E. We don't find it for the right angle because the hypotenuse and the opposite would be the same thing. We don't do that. Okay, so when it says find the sine, cosine, and tangent, it literally wants the ratio, which we leave as a fraction, only. You don't do anything else. You find the fraction, you simplify. That's what the sine, cosine, and tangent are. So we're going to do that with example 1. We're going to start with angle D. And the sine of angle D. Those of you that have used these should have them memorized by already, but if you do not, that's fine. We've got it on the outside. Sine is, look on the outside, opposite over hypotenuse. What is opposite to D? 14. Opposite means across from. What is the hypotenuse of this triangle? We need to reduce that fraction, which in case you don't want to do, the calculator will do it for you, or you can realize that 2 goes into both those numbers. You said it was what? That's as far as I go. I'm not typing anything in the calculator. It didn't ask for a side length. It didn't ask for the angle. It said, what is the sine? The sine of the angle D is 7 over 25. Let's go to cosine of angle D. Cosine is adjacent over hypotenuse. What does the word adjacent mean anyway? Touching. Okay, there's 2 touching, but one is the adjacent, one's the hypotenuse. What is touching that's not the hypotenuse? Over the hypotenuse, we need to reduce that as well. Yep. 24 over 25. Tangent of angle D. Is opposite over adjacent. What is the opposite again? What is the adjacent? What does that reduce to? It says also do it for angle E. Angle E is here. Sine of angle E. What is the opposite of angle E? What's the hypotenuse? What does that reduce to? What is the cosine of E? 14 over 50? Okay. What does that reduce to? 7 over 25. What is the tangent of E? 48 over 14. What does that reduce to? 24 sevenths. Does anybody notice anything looking at these two? The cosine and sine are the same they're called complementary angles because they're add up to 90. The sine and cosine, again, here and here are the same. That is always true and will save you time if you ever have to do all these. They are always the same. The sine and cosine are the same of 2 complementary angles. The tangent, as you guys said, is just the reciprocal. can save you some time. You're going to find all these ratios for example number 2, but before you can do that, what is missing from example 2? How do we find the hypotenuse? Pythagorean Theorem. Go ahead and say what you were saying. 2 squared plus equals. We're going to leave it as a perfect square today, too. 2 squared is 4. 3 squared is 13 equals c squared. We did this yesterday. Is 13 perfect? It's prime. That means nothing will go into it. That means c is just the square root of 13. We can't break it up like we did yesterday. Alright, using those 3 values, I need you to find the trig ratios for both angle A and then for angle B. Using the trick will make it a little faster, not the trick, the relationship that we discovered. Alright, I'm going to start with sine. It doesn't actually matter which one you start with. I just started with what it said to start with. Sine of A. Sine is opposite. What is opposite of A? Over hypotenuse. What's the hypotenuse? I've got a problem with this, and I'll tell you what that is in a minute. How about cosine of A? Okay, got a problem with that one too. Tangent of A. That one's fine. We're going to leave it alone. Did you guys use the trick, and not the trick, but the rule instead of finding them all over again? Okay. If you didn't, you're looking at this angle. But if you did, sine of B is the same as what? So we're going to come back and fix that. I'll tell you why in a minute. Cosine of B is the same as, and tangent of B is the same as the reciprocal. Here is my problem. It is not, I don't know what the right word is. It's not that it's not correct, because that's still a number, but it's not like, most people don't like to leave a square root on the bottom, so they get rid of it. Not get rid of, but they change the fraction in a way that would make the square root not disappear. I'm not using the right words, but not be on the bottom anymore. How do you undo a square root? You can square it. What else can you do? What is squaring it actually doing? Multiplying it by itself. But we can multiply by the square root of 13 over the square root of 13 because what is the square root of 13 over the square root of 13? It's 1. 3 times the square root of 13 is 3 square root of 13. What is square root of 13 times square root of 13? This is what you'll see. You will not see a square root on the bottom. We're just going to write that down for cosine of B as well. We have to do the same thing for cosine of A. This is called conjugating. No, rationalizing. Conjugating is when it's a rational expression. Rationalizing the denominator. So what do we have on top? And square root of 13 times square root of 13. We're going to write that over here as well. Some of you will notice a pattern and not have to do that over and over again because it's just this comes up and stays on the bottom outside of that square root there. Okay? we're going to go down and talk about special right triangles. We'll actually do an entire lesson on special right triangles. We're going to talk about these 9 down here today, but the first 3 go with this triangle. The next 3, no, the next 6 go with this one. (45, 45, 90) and 30, 60, 90 are special triangles that we'll talk about later. But for now, let's talk about finding the sine of 45 degrees. Does it matter which angle we pick? No. I'm just going to pick this one. What is opposite of 45 degrees? 1. What's the hypotenuse? Do I need to rationalize that denominator? Meaning, do I have this radical in the denominator? Yes. Square root of 2 over 2. Do the same thing for cosine and tangent. Why would cosine be the same? The same angle? Not that it's the same angle. It's because they're complementary. If they're complementary, they're the same answer. So then we're almost done. Let's do tangent at 45 then. What is tangent? 1 over 1, which is just 1. In Algebra 2, you'll talk, or maybe even, it might not be Algebra 2, it might be Pre-Cal, it depends. You'll talk about something called a unit circle. These are very important in the unit circle. Okay, just like these two were the same, what will be the same in the next set? Sine 30 would go with cosine of 60. Cosine of 30 would go with sine 60. I want you guys to work on that section. This says square root of 3, by the way. Okay, sine of 30. Here is 30 degrees. Opposite of 30 is 1. Hypotenuse is 2. I like that one. I don't have to rationalize the denominator. What else can I fill out, though? Cosine. Okay. All right. Now, cosine of 30. Cosine is adjacent over hypotenuse. Oh, I like that one. I don't have to rationalize it either. What else is square root of 3 over 2? So I thought you had to do more, but evidently I was wrong about that. You only had to do 1 rationalizing. All right, tangent of 30. What is tangent? Opposite 1 over adjacent square root of 3. There's the one you have to rationalize. Some of you do not write this step anymore because you realize what you can do, but if you still are a little shaky, you should probably write it down. Square root of 3 over. Instead of looking back at the triangle, how do I figure out what this one is? Reciprocal of this original one, which is square root of 3 over 1, which is, very good. Glue this in on page 110. I'm going to pass out another one, of which we're only going to do 2 questions. We will do the others tomorrow. It'll be a nice stopping off point here.
All right, now that we are done with those examples, we're going to glue this one in on 114. Do not forget, you need to be memorizing this. You'll probably have a pop quiz sometime with those. I'm warning you that that will probably happen. Okay, so glue that in on 114. Go ahead and get started on the practice that has been assigned to you. No, you will not be able to finish it all. Do as much as you can. You'll have to watch the second video to be able to do all of it.